Yeah, so today I'm going to spend my time talking about an open source project that's very dear to my heart. It's been something that has been brewing for a few years, but actually in the last year we've created a major part of the implementation, and we're starting to see some very positive results. So what's the background to this? We've been talking about big data and AI and how fantastic this is going to make the world. We're talking about applying the use of this data across every part of our lives. So creating new types of capability and services, linking them together. And I've been very interested in data, and also I work with a lot of large companies who are desperate to make this work. You know, they're looking for every aspect on how they can make this work. But for many of them, they actually fail. They manage to get something working for a very specific use case, a very specific set of data, but they can't make this work generically. They can't become what they call a data-driven enterprise, where people have got access to the data they need. They can combine it. They can create new insights as and when they need it. And this is not about people randomly picking up data and using it. This is about subject matter experts in their field wanting to use data to make decisions. So when you actually start looking at why this is so hard, you realize there's a fundamentally missing part of the way that we build IT systems. And it was touched on perfectly by the first two keynotes, which is really about data as a thing. Whereas when you think about the way we're trained in software engineering, we hide data behind services, and it's supposed to be private to those services. And there's a whole set of assumptions around that meaning of that data and how it should be used that's hidden in that data. And then we come along with our big data systems and our AI ideas and want to use the analytics, and we rip that data out of those systems and expect it to be instantly understandable and things. And so you end up with having to do this manual process of attaching metadata to this data, which was actually designed for a very specific purpose. And we hope that through attaching this, it becomes generic. So I'm going to take you through a little bit of the thinking behind how we could possibly change our infrastructures and the way that we manage data. In order for this to work, it has to be an ecosystem. It has to be something that everybody can be a part of, and it has to be available for free and not requiring somebody with a PhD in computer science or whatever in order to use it. And that's one of the reasons why the project I'm going to talk about is open source. The best practices around it are open source. The aim is that the way it is built is open to all as possible, because we want to embed it into our infrastructure. So let me talk a little bit about context. Often people who are not experts in data have a view that data is about facts, and facts are immutable. You know, here's a fact: where you live. Hopefully you know where you live, and you feel that that's a fact. You know what that is. Now, if you talk to, say, a 5-year-old who's just learnt their address, and you ask them where they live, they chant their address to you, right? But as an adult, you have a more nuanced response. So imagine you're in Florida on holiday, and you've just met somebody, and they say, where do you live? You say, I live in the UK. You don't give them your address. You say, I live in the UK, because that's all really what they're asking is, roughly where on the planet do you live? If you're standing in your street and a new neighbour comes up to you and introduces themselves and says, where do you live? You might say, I live over here. Now, the answers that are coming out are different because of the context of the question. And if I was trying to adapt an address data or the information about a location of where I live, that has a context as well. So what we need to do when we use data is match the context in which it was collected with the context in which it's being used. And this context information we call metadata. So there's a little picture with it around. Now let's look at an environment where this works very well. If you imagine in the olden days, we had photographs printed on paper, and we relied on everybody to write on the back that this was Auntie Flo's wedding, or so-and-so's birthday party. It happened on this date, and we were in, I don't know, in London. And some people were very good at that, but most of us were absolutely terrible. So we have shoeboxes of photographs that we're not really sure which relative it was and when was this particularly taken. Now you look at a digital photograph, the phone or your camera collects information about where you are, what was the setting of the camera, what were the lighting conditions. And that's actually stored with the data. You could take it off an iPhone and put it into Adobe product, and hey, that's all readable. You can augment it and store additional information, like this was Auntie Flo's wedding, or I took this photograph for a certain reason. And that goes with it as well. So the context of the creation of this photograph flows with the data, which means it can be matched with the context of its use. With this information, suddenly the processing of photographs becomes much easier. So we could take lots of photographs that have all been taken by different cameras, different times of the same place, and start to make assertions about what's happening to that location over time because of the common metadata. Now, our metadata standards people have been hard at work. We have thousands of metadata standards. We are not short of standards. But what we haven't got is them stitched together into a framework where they can actually be used generically across all of the use cases and the metadata that's actually needed. And that's what this project is trying to do. It's saying, let's build on all the fantastic work that's been done and turn it into something that someone can download and start using, and that includes standards that can be embedded into databases and AI tools and data movement tools and things that actually start working in the way that digital photographs work today. So I talked a little bit about the fact that we take our data out of these protected environments called applications. And this is where most data comes from in enterprises, is from applications. Enterprises have literally thousands of systems with duplicated data across them. So one of my customers in the US reckoned that they were deploying a new customer database every week. So you can imagine that and they put synchronization between so that they can be constantly updating the customer names and addresses. But you can see that it becomes a very fragile system where they're relying on things working and linking all these data together. So here we have our very vulnerable data that's now been pulled out of an application system. And Marcus mentioned that there was a huge industry in managing this data once it's pulled out. Whoops. Oh, I'm sorry. I've stepped into a different place. So let me just skip past. Whoops. And I'll go back to these. Right. So this big industry is a thing called the metadata repository, and there's a whole set of tools around it that allows you to retrospectively capture the context of the data as part of the process. And the idea is, with these types of tools, I'll zip back to these use cases, which I meant to cover first, we can actually start connecting people across an organization, because often the consumer of information actually is just looking at this data, and there's bits they can recognize, but there's lots of numbers in there that could be anything. And there'll be somebody on the other side of the organization that actually does know what this data is. And one of the things that's slow in environments is finding that person and getting them to sit down and explain what this data means. So really what you want is these metadata tools to actually, click on, I want to see this data, and it come up with everything that everybody knows about this data, how it's been processed, where it's come from, what we call the general metadata description. And this sort of environment is often called a data catalog. And if you search on that, there are a great many companies offering the idea of this data catalog. The next issue is that often organizations are scared to share data. So this is actually HR data from a particular company. The head of human resources wants some analysis done on it. The problem they have is that it includes salary and bonus information, and Callie is an employee. So her data is in here. Even if you don't tell her what all the columns are, she can work out what everybody earns from that data. So in some ways, we need to be able to automatically mask, transform, merge data when an employee accesses it based on who they are and what they're doing, and the level of trust you have. Now, this can be done in certain circumstances, but there's nothing that automatically manages it. It can't be that HR says salary and bonus information is personally sensitive and is only available to certain people under certain circumstances. We have to encode that into every platform, every tool that is using this, and that is incredibly expensive. And so there are gaps in an organization's protection. So these are a couple of problems. The other thing is that most tools, with the best will in the world, don't cover everything an organization needs. And so what happens is they end up buying lots of tools, and each one comes empty, and you end up having to redo all of that definition and coding up about what you need to know about each data source. Each metadata repository is proprietary, so there's no easy way of moving the data between it. So the first problem we need to solve is how do we allow these repositories to exchange metadata in open standards? It needs to be peer-to-peer because these are different vendors. They have their own business model. None of them will all support exactly the same metadata. There'll be common subsets, but there'll be some that are unique to each one, and we need to be sensitive to that. Each tool is written assuming they are the only metadata repository in the world. And so they have the protocol has to allow that assumption to continue because it's incredibly prevalent in the industry. So this is one of the things that the Egeria project does, is actually enable this peer-to-peer. There's a library that each embeds, and that handles all the protocol exchange, the transformation of metadata between each of the repositories. The way it works is that you don't exchange metadata with every tool in the world, but you create what's called a cohort. And a cohort is a set of tools that are supporting the same group, a part of an organization, for example, and the metadata is exchanged in a peer-to-peer manner. So each choose what they expose, each choose what they receive, depending on their capability, and also the user's preference in terms of what they want to see. But what generally happens is that each of these tools has a user community around it. They have a focus, and the metadata is created according to that focus. So you almost have the people who know what they're doing in any particular area creating metadata locally. And then a read-only copy is then exchanged with the others, and it's fairly fine-grained. It's a virtual graph structure, and so we can link it together and create new value as the metadata is exchanged. And because organizations are complex, a particular repository can join multiple cohorts and see a bigger picture. So here we've got the Chief Data Office wanting to see everything, whereas different parts of the business may be connected either to cohort A or cohort B, and they will see their own subset as a result of the protocols. So that's one of our problems. With this type of exchange, as I said, it's a graph. And so we have entities and relationships and classifications on top of it. That's the meta model. And then a type system that allows us to talk about database columns, semantic definitions, relationships between has's and is's type relationships, etc., throughout it. And the reason that we've used a virtual graph is when you actually start looking at metadata. So here's some data. Here's some schematic data, say, from a relational database that helps us break up the columns into fields, break up the data into columns. Then maybe some definitions. So this could come from schema.org that we talked about before. And then overlaying an ontology on top. So what you see is the metadata here is quite graph-like in its structure. It's also added by different expertise to actually build up the whole picture. But once you have this, you can start doing things like annotating the ontology part with governance information. So this is saying that anything that's linked to a compensation plan is actually sensitive data. So the top piece is the bit the business sees. The business can sign off and say, this is what I want. And then through the distribution of the metadata, linking right down onto each of the data sources and putting that understanding into the engines, we can now make sure that if we then change our mind and say compensation plans are no longer sensitive, or actually job title is now sensitive, one change in the metadata repository and that distribution then means that the same rules start to be applied across the organisation. It becomes a lot easier to convince an auditor that you know what you're doing, and also the cost. I mean, the amount of money that large companies are spending just copying metadata, re-implementing the same rules in lots and lots of different engines is enormous. So let's talk a little bit about what's going on under the covers. So here we've got two metadata repositories, and they each have a different community, and one of them has loaded up information about a data set, and so it has a notion of a database column. And another one has some experts who've created a semantic model of data. And we want to link the two together, but they're actually sitting in different repositories. So there are a number of approaches that the Egeria software will do. The first is it will create a read-only copy of, say, the glossary term, and allow the link to be created between it. And that's good if server 1 supports glossary terms and meaning relationships. But it might not. So it might be that you bring a third server in that's got a bit more capability, and we can bring those nodes down and connect them together in a different server. So through this process of combining servers, we actually can start augmenting the overall capability of the cohort, because we can selectively share and control the updates of the metadata. And we also have a little trick here called the entity proxy, which allows us just to store a stub, effectively, of a particular node, particularly in a server that maybe is not able to support the full value. But it's enough to find the database column, the real definition of the database column. And that's also very useful if the database column information is changing very rapidly, and it's expensive to keep it replicated. So just knowing its address is actually very useful in that case. So we have different philosophies and capabilities within the software, and these are automatically managed depending on the performance and availability requirements of the metadata. Now, I talked about how important it is not just to keep this metadata and prize it and love it, you actually want to be able to use it. So the first capability was this open metadata highway. This is the linking piece. And we use data movement, but we also use federated queries. So if you then say, I want to update this field and it's not in your local repository, the update request will be automatically routed to the correct repository, updated there, and then distributed. So we only ever update in one place. The other thing is that we need the open APIs to control the tools and security tools. So the first use case we did was to basically set up policies in one repository, have them flow to another, and then have that configure tools in the open environment. And we did two things. One, could we control access dynamically from the metadata? And two, could we control the view of data? So rather than when a business user asks to see a data set, rather than the columns being the actual schema names, we replace the schema names with the business glossary terms, with the semantic definitions, so they see consistent naming of things in the data sets, irrespective of how they've been implemented. So we've had that going. This is the configuration. So we've been playing with one of IBM's products, Apache Atlas, which is an open source metadata repository for Hadoop, and the Egeria software. And so basically the definitions are all happening in the governance catalog. Information about data is in Apache Atlas. And from that, we are able to configure data virtualization views over the data using glossary terms and use Apache Ranger to control access so that sensitive data is automatically masked or not available to different users depending on the policies. So this was a very large MVP, but it actually was necessary to prove that we could bring fairly different types of technology together into a coherent ecosystem and take policies from the business and run it down into the operating environment. And this is about how we create proof points that then allow us to persuade different open source projects, different vendors to actually invest in this technology, because the bigger the ecosystem, the higher the value of having open standards around it. Because when you start looking at what do we need to cover, there are a huge number of choices. From governance, ETL, virtualization, I mean, this is just a very small subset of all the types of tools that could benefit from good metadata. So we have 2 layers. We have the repository services that give us that metadata exchange. And then we have what we call the access services, which were the ones that controlled Ranger and the Guyan database, which are targeted at particular domains or different domains within the data industry. Building the repository services is just a case of taking our knowledge about data integration and applying it, and that's the implementation there. But when we get to doing the access services, it's a very different approach, because we need each access service to serve a particular group of people. So we end up with a lot more focus on design for that group, ensuring that API is as easy to consume as possible, rather than requiring them to embrace the entire breadth and depth of metadata for the entire world. We have a fake company called Cocoa Pharmaceuticals, which has about 25 personas from different parts of the business, each trying to do something with data. The organization is under a massive business transformation, moving them from traditional medicine to personalized medicine, so there's a lot more use of data. The sort of static batch processes are all becoming very dynamic, so that everything is changing in their business, and it takes them through the process of how they do that transformation. There's been proper user research behind these personas. They're actually based on real situations and real people, but obviously the names here are all designed to demonstrate that they actually hide the individuals involved. And so we've defined the types, which APIs we need, the API designs, and also we're building best practices around it, because there's actually a lot of, there's a very small amount of knowledge across the industry about how you govern data in a way that is not draconian. Everybody involved in governance should actually get value from their use. So an example of that is one of my customers were building a lot of APIs. Their API developers didn't do governance because they were agile. But what they did was they enhanced the Swagger tooling to take metadata definitions, and they would generate standards for things like the customer JSON structure. And so the developers just drag and drop these standard formats into their APIs. They were much faster. Those APIs were all tagged up with information about which glossary term they meant. So when the API was deployed, the DevOps pipeline could pick up those tags and go, oh, wait a minute, we've got sensitive data going in here. This needs to go into a properly secured database. The API needs to go into this gateway. It needs this type of secure access. So that tagging was then used to drive how the deployment was done, and they had complete traceability from their APIs, from the development of their APIs through to the deployment, and proper identification of data. And the developers love it. They want more, and that's the way governance should be, is that every user involved gets something back when they put something in. And it's a positive thing, not a we hate governance because it stops us doing stuff. So that's really where the best practices come in. And often when you start people thinking differently about governance, suddenly these types of synergies occur. Now, the other thing is when you start looking at different people and what they want, each of them think that they've got a hierarchical structure of metadata that they need, but the node at the top is different for everybody. And this is why you end up with a graph, if you think about it mathematically. So part of the use of the personas actually allows us to demonstrate that the graph is necessary, because there's a lot of belief that you can do all this in a document, basically, and you really don't get the value until you start thinking about this as a graph. The other thing is it's very event-driven. So someone might create a database, somebody needs to own it, somebody needs to classify it, and then it's available for use. So it's how do you enable that exchange between different subject matter experts or different systems, because these could be automated processes rather than people, as possible. You really can't have one big thing that does everything. It needs to be this sort of event-driven environment. This is the scope of the metadata we're focused on. from, obviously, the assets, and this is feeds, APIs, data sets, you name it, anything that holds data. The semantic piece is the glossary area. Collaboration is crowdsourcing of information, feedback, usage, likes, ratings, all that sort of thing. Models and reference data. So this is where we establish standards around data. This is the automatic analysis of data and tagging of annotations from automated processes. Understanding the infrastructure where things are, incredibly important for data sovereignty, for data protection. Lineage, where did stuff come from? And the governance piece, which is really about classifying and then defining how data of different classifications should be treated in different perspectives. It also covers rights management. If I go to the next level, and these are all available to you, so if you find this difficult to read, and it's also on the Egeria site. It's not just, data now isn't owned by the organization that's using it. It comes from lots of different places, and it has a different license associated with it. So license management and the rights associated with data needs to be a core part of the data catalog. And so that is actually a key part of the governance piece. Here we've got the different APIs that we're building, the access APIs, these high-level APIs. And you'll see that we have software development, DevOps, digital architecture, and then the more traditional roles, the consumer of assets, the owner of assets, the subject area is the ontology or subject matter experts API, privacy, and the traditional governance pieces as well. And these are all the things that need to come together, and we're still adding APIs as we pick up new use cases. So as you can see, our ambitions are somewhat large, but we're really not getting any pushback. So many vendors, you would think, who've made money in this proprietary way actually start to see the value of stepping back from building their own metadata repository to actually start applying and using metadata more effectively across the ecosystem. So we are getting a lot of very positive feedback from people. We have two projects, both under the ODPi, and the ODPi is a Linux Foundation organization. One of them is called Project Egeria, which I talked about. That's the code and the compliance suite. An open compliance suite is critical because people buying vendors' products that claim to be compliant can run the compliance suite during the proof of concept. So that's important. And then also these best practices pieces. So we bring practitioners into the best practices part and vendors and other consumers into the technology part. And these are the 4 companies that are focused on delivering the function now. We are looking for lots more people. If you buy this type of technology, please tell your vendors that this is very important and you want it, because it's pressure from you that will actually force the vendors to comply. If you want to help, we are looking for developers. If you think that this is a good idea, you can fund the ODPi, and we will use that for development and marketing and other types of aspects around just running the organisation. So we're really looking for help, and that just leaves questions if we have time.
Great. Big thank you to Mandy. We started slightly late, but I think we've got time for a couple of questions.
Yeah, good morning. In the metadata, do you think there should be data about the correctness of the data? So, for example, I work a lot with genealogy. You look at an old census, the lady says she was 29, you know for a fact she was 35. It would be interesting to add metadata so that other researchers can say there's some indication that this data is actually inaccurate. And then would you have governance of who can update the metadata, not just the data?
So the short answer to both of those is yes and yes. Metadata is data, and we use all best practices around managing it as just as data. And in fact, you get an increasingly blurred line between the two. And in fact, what is master data, reference data, metadata, and data? Actually, you start to realize that it's all depends on the perspective and context. And so the longer answer is that when it comes to quality is very contextual. So what is good enough quality in one aspect? Like if somebody really believes that they're 25, and want to dress like that, a retailer will be stupid not to sell them clothes for 25-year-olds, right? But if it's a medical condition, then actually the fact that they're 58 is important. So quality is definitely something that always has to have context around it. And all annotations really need to capture the provenance of themselves, as well as the fact that they're trying to capture provenance and quality about the data itself.
I just wanted to know how easy you found it to get vendors of the proprietary systems to buy into what you're trying to do here. I'm sure there's a great deal of reluctance.
It's actually the other way around. So we get a lot of enthusiasm. And the thing that takes the time is actually many of them have never thought about distributed metadata. So most of them write their metadata repository like an application in a closed environment. They don't actually know what their metadata means. It's hidden in their code. So these are applications very like dealing with an ordinary application in a company. So what's slowing us down is actually the time taken to take them through helping them understand their metadata, integrating it into mapping it to the open types, and actually getting that integration done. So if there could be more of us doing this, then actually we'd be faster. I'm really not getting vendors saying, I don't think it's a good idea. I like my proprietary. Now, it might be that the vendors I talk to are more open to openness anyway, but I've not had any pushback. It's just really the resources to actually do the integration that's a problem.
Oh, thank you.
A lady here.
Great.
One
Okay,
here.
so sorry.
Just one here.
Got time for one micro question. That's okay.
Thanks very much.
Yes,
I'll
or
try and
answer
keep
no.
it short. Linda Gross from IOP Publishing. One of the question for me is what's your major goal? Is it more about establishing standards to change the interoperability of commercial solutions, or is it something that you also see as something that smaller businesses can use to get a handle on this if they can't afford a commercial solution?
Second, for me personally, I'd like it so that all organisations have access to this type of capability. So because you can, lose your identity from a small company or charity as much as from a large. So for me, from a societal point of view, I think it should be available to all. But it will be done through the financial power of the larger vendors. So it's almost like the bootstrap has to be done through the vendors to get the buy-in. But the resulting system should be usable by any organisation of any size. Okay. So I think that's it. So I will be around all day.
Big thank you to Mandy.
And if you'd like a laptop sticker for Egeria, please come and ask me as well.